Okay, Assalamu alaikum to all participants. We are going to start our discussion for today. We are into 14th week, and this is your second lecture of week number 14, right? So, yesterday we started an introduction to exception handling, right? So, I'll give you a quick recap of what we had discussed yesterday, and then we will continue our discussion onwards, right? So exception is an error, right, which occurs at runtime. At runtime means that there is an error which occurs during the execution of the program. So we had seen different examples of what are exceptions. For example, division by zero is a very common cause of exception. Then we had seen maybe if you are trying to read data from a file and the file does not exist, right? So your program will crash. Similarly, if you are trying to write data to a file and you do not have access, you do not have permission, so again that can lead to an exception, right? So you see, in the first place, we should make our best effort to write a program in such a way that a situation like that does not arise, right? But we cannot guarantee that a runtime error will not occur, right? Because we discussed that in many cases you have to interact with the user, so you cannot guarantee what the user would enter, so there are chances that some runtime error can occur, right? So if the error has occurred, if we cannot prevent it, then at least we should have some graceful way of handling it, right? So the piece of program that executes when an exception occurs is called exception handling, and the job of this program is basically to make sure that your program does not crash. Okay, we don't want our program to crash, we just want that our program should be should continue, right? And we cannot we are not in a situation where the program is abnormally terminating, right? So today we'll see some more examples of it, right? But before that, let me just discuss the flow of how things work. Okay, so you see, suppose you have some piece of code here, right? Okay, let's see, this is your main. Okay, and within main you have some piece of code here, and then you have a block which is like the try block. So this is your, we have some statements here, then this is your try block. Okay, and then as you know that immediately after the try block you have this catch block, which will have some error messages, and this is the piece of code that will execute when there is an error. And then you will have some statements which is like your regular flow of program. Okay, so now let's see, we will just be discussing the sequence, okay, before doing any further example. So you see, your program will keep on executing. So I'll maybe we'll have two paths depending upon whether there is an exception or not, right? So you see, this path will execute, let's assume there is no error. Okay, so first we'll execute this, then this is the piece of code in which we are expecting then that some exception can occur. So if there is no exception, then this will execute completely. That catch block will not be executed. If there is no error, catch block is not executed, so it will be skipped. And then whatever is after the catch block, this will be executed, right? So this is your normal flow of program, right? Normal flow means that there is no error. Okay, there is no exception. Now let's see what will be the flow in case some exception occurs, right? Maybe from a statement in the try block. So of course, whatever is before the try block, it will execute. Okay, then suppose this statement here, which I have highlighted in red, this causes an error. Okay, and maybe we have some statements after it as well. Okay, so let me just put one more line so that you have some statement here as well. Okay, and this second statement is causing an error. So now what will happen, your program will execute this statement, it will come on this statement, right? Means till here. But as soon as there is an error, what will happen, the rest of the try block will be skipped, and your program will directly jump, where it will jump to the catch block. Now this will be executed. okay, because this is the part where you are giving error messages to the user. And then of course when the cache block ends, so whatever is after the cache block, that will be executed, right? So now you see the difference between these two. Let's discuss that. This is executing in both the cases, okay, whatever is before, and similarly whatever is after the cache block, this is executing in both the cases. If there is no error, try block is completely executed and the cache block is skipped, right? Because cache block, it is giving error messages, it is handling the exception. If there is no error, there is no need to execute it, right? So if there is no error, cache block will be skipped. So that's why you see this blue arrow, it will skip this part and then it will continue execution after the cache block. Now if an error has occurred, for example on the second line, then everything remaining in the try block is skipped, right? So this is not executed. If there is an error, the statement on which error has occurred, okay, you would have used the keyword throw, and from there the program control will directly go to the cache block. So the cache block will execute in case of error, and then of course once the cache block terminates, you will have rest of the program that will execute, okay. So this was a flow of sequence, right? And we'll keep on repeating this through different examples. So yesterday we had seen an example of a program that was allowing us to enter marks for a quiz, and we said quiz marks cannot be negative and cannot be greater than 0, right? So I had shown you that program. Today I'll be writing that program on the compiler, and then we'll discuss further the same thing, okay. So let's see. I hope you can see this online compiler which I have shown you on the screen. So let's write the program which we did yesterday. So we take an integer quiz marks. Okay. Now we can make a try block in which we'll ask user to enter the quiz marks. Okay. And as soon as the try block ends, we'll have a cache block. I will complete it later. I'm just filling, you can say making this outline. Okay. So you have a try block, and once your try block ends, you have a cache block. Okay, now within the try block we put all the statements in which we doubt that there can be some error, right? So we ask the user to enter quiz marks. Okay, and see in we say quiz marks. Okay, so user will enter some marks. Now we say, okay, if the marks have an illegal value, we must throw an exception. This is an error, we do not allow it. So we must tell the user that some problem has occurred. So we always, in order to check for error, you will use an if condition. Okay, and you will decide what should be the if condition. So we have decided that quiz marks cannot be less than 0. If quiz marks are less than 0, this is an error. Similarly, or if quiz marks are greater than 10, this is also an error. Okay, so if this if condition is true, it means some error, some exception, some problem has occurred, right? So when there's an error, we use the keyword throw. Okay, so as I told you, it's a keyword. And after throw, you can write any variable. You can throw an integer, you can throw a string which is a message, you can throw a character, any data type, right? So we were saying that okay, we will throw the quiz marks which the user have entered, okay, the illegal value of quiz marks. So I'll write throw quiz marks. Okay, and if there is no error, then I will simply display the marks to the user. Okay, so I'll say marks, and I will write quiz marks and line. Okay. Now this was our try block. Now in the catch block, I told you that catch block takes argument just like a function, right? And yesterday we discussed that whatever you throw, you will catch the same thing. What are we throwing here? We are throwing an integer, so it means it is accepting an integer as an argument. Okay, if we are throwing a message like a string which is an error message, then I will write something else here, right? It will be catching a string. So whatever you throw, you catch the same thing. We are throwing an integer, so we are catching an integer, right? M. Now quiz marks will be passed into M when you arrive at that statement, just like it happens in a function call. And cache block, as we discussed, is executed when there is an error. So here we have to give an error message to the user. So we can write maybe invalid value of marks. And what is that value? M. Enter. Okay, so now we are giving user a message that you have entered an invalid value of marks. Okay, and then after the catch block, we can have other statements like maybe whatever you want here. Program continues here. Okay, means you can have other program part of the program here. And what you can do, if the user is giving illegal value, normally what we do, we assign a default value to the variable, right? For example, if user is giving an illegal value to this variable, we say we'll assign it to 0, so that when our program continues, we do not come up with a situation where our program crashes, right? So what we have done, in case the user has given illegal value, we'll assign it a 0. Okay, now this is the program on your screen. Now let me just try to run it, and then we discuss the flow of the program. Okay, so once we run this program, let's see if there is some error or not. Yeah, it works fine. So it is asking us to enter quiz mark. So we are on this statement, the first statement in the try block, where program is asking enter quiz mark. So let me first enter a valid value. So I have entered 8 as quiz marks. Okay, so now 8 is a correct value, so the if condition is false, so the throw is never executed, right? And we come to the next statement in the try block, which is simply displaying the value of quiz marks, which I have highlighted, right? Since there is no error, so the cache block is also not executed, and then the last statement in the program should execute. Okay, so we see, I have entered the quiz marks, and you see it is displaying the value of marks 8. So it means that this statement is executed, which is the last in the try block. And you see the cache block is not executed. You do not see any error message on the screen, and then the program continues later. Now let me run the same program, but this time we'll give it an invalid value. Okay, so let's run this program again. Okay, and it will ask us to enter some value. So now I'll enter, say, -5. Okay, -5 is not a valid value, so your if condition is true. When the if condition is true, you come on this statement throw quiz marks. So as soon as your program arrives on this statement throw, it will skip everything in the try block. It will directly jump to the catch block. So now it will jump to the catch block, and it will show you the error message. Okay, so now okay, sorry, just a moment. I Yeah, now you see invalid values of marks -5 entered. So this is the statement, the first statement in the cache block that you see printed on the screen. Whatever was quiz marks, we passed as an argument in M, so that we can tell the user that what is the invalid value you are entering, because it is possible that user is entering many variable values, right? So user should know that what was the invalid value that was passed. Okay, so now you see the error message on the screen, invalid value of marks -5 entered, and then quiz marks will get the value 0, and the last statement, which is outside the cache block, it is executed. So this part, the last statement, is executed in both the cases, whether there is an error or no error, right? Cache block is only executed when there is an error, right? And if there is no error, cache block is skipped. And whenever there is an error, the keyword throw tells us, and from throw you directly jump to the catch block, right? So this was example from yesterday with some more details that we could not discuss in the previous session. So now from this first example, if you have some comments, we can discuss. Then we'll move to a couple of other examples related to exception handling. Okay, now let's continue our discussion. You see, with a try block, you can have multiple catch blocks. Okay, with a single try block, you can have different catch blocks with different arguments, right? But you should be careful that when you have multiple catch blocks, only the one of those catch blocks will be executed. Okay, so now let me just change it. I write catch float m. Okay, and then I copy the same statements here. Okay, now you see, for the one try block, I have two catch block, one which is accepting integer as argument, the second one is accepting float as an argument, right? Now why we need to do this, because it is very much possible that in addition to quiz marks you have also float GPA. Okay, so if suppose the error is in quiz marks, we throw an integer. If we throw an integer, the corresponding catch block will execute. If the error is in GPA, I will write throw GPA. Okay, and then this catch block will be executed, right? Because the example that we had seen, we had only one variable, but if you have multiple variables, they will have different data types. So what will happen is that you will have multiple catch blocks, and whatever you throw, if you throw an integer, the cache block corresponding to that will be executed. Otherwise, if you throw a float, the corresponding cache block will be executed, right? So now you see, you can also have a situation where, suppose someone, I remove this cache block, okay, integer one, I keep the float one. So now you see there is a problem, that I am throwing an integer, but there is no cache block for an integer. So you see, this cache block will not be executed because it needs a float. I don't have any cache block with an integer. So normally what we do is, we can also have a default cache block, right? And what we do, we write a cache, and within that you put three dots. Okay, so three dots means that it can be anything. For example, if I'm throwing an integer and there is no cache block for an integer, the default block will be executed. If I'm throwing an integer and there is a cache block for integer, then of course that will be executed. The default is executed when there is no matching cache block, right? And here we can give an error message, maybe unknown error, because we don't know what caused this error. Okay. So now you see what will happen. If I enter an invalid value of quiz marks, I'm throwing an integer. This cache block is for float. It will not execute. There is no cache block for integer, so the default cache block will be executing. Right. So this was just a piece of information that was important. Okay. So let me just go back to the slide so that we can see quickly this example. Okay. So this was the example we did in detail. Okay. And I told you that suppose you have an integer, you throw an integer, but you don't have a cache block for an integer. So again, your program will you will not show any error message, right? Because this cache block will not execute. So that's why it's a good idea that you always have a default cache block. For a default cache block, you just put three dots in the argument list, and then if there is no matching cache block, then the default one is executed. Okay, so this is it's a good idea that you should always have such a you can say default cache block in your program. Okay, now we have seen example in which we are directly you can say throwing exception from the main, right? But we'll now be extending this program that will be making a function, and that function will be actually throwing some error. Okay, so let's go back maybe to the compiler, and let me write some program. Okay, so I'll get rid of the things we don't need, and now we'll be writing another program. Okay, so this time what we do, we say, okay, let's make a function. Like, we say, okay, integer divide integer x integer y. Okay, so we are making a function to divide two numbers. Okay, although it should be double, because answer of division can be float real number, but anyways, I'm taking integer. We'll truncate it to an integer. Okay, so now you see, in case of division, what can cause an exception? If your denominator is 0, right? So if y is 0, okay, then it means there is an error. Right, so you can throw something. So this time what we do is that, instead of throwing an integer, let's throw an error message, right? So that we simply throw the error message, and user will display that error message in the cache block. Okay, so I say throw, and after throw I just write a message, division by 0. Okay, so this is what I'm throwing. And if there is no error, okay, what you do, you return the answer is x divided by y. Okay, now you see, you must have noticed that with if I am not using else. The reason is that, in case if condition is true, throw is executed, and from throw your control directly goes to the catch block, right? That's why I'm not using else. Even if you use else, it's okay, but there is no need to use else, because if the condition is true, the throw statement would be executed, and program will directly go to the catch block, and the rest of the function will be skipped, right? That is why I'm not using else with this if. Okay, now this is a divide function. Now we come to the main. Okay, in the main, what we do, we say, okay, I have two integers, a is 10. Maybe I take in the same line so that you can see b is 2, and we have c. Okay, now I will divide a and b. Okay, and I will store the result in C. but the divide function which I am calling, it can cause an error, right? Whatever is throwing an error, that must be surrounded by a try block. So what I will do, I will make a try block. Okay, and here I'll have catch block, which I will complete later on, and then I will have the default catch block, something like this. Okay, now in the try block we will call this function. So we say C is divide a comma b. Okay, and then we write the answer of division, which is in C, so we display it to the user. Okay, now this is the try block in which we are calling this function. If there is an exception, right, so what we are throwing an error message, right? So since this we are using C style, so instead of class string, I'll have to use it as a character pointer, right? Because if you simply write a string in double quotes, then it is treated as a character pointer, right? On the other hand, if you take a variable and then throw, then of course you can use the string class. So I'm not using string class here. So now you see the function is throwing error message. So what I can do, I can simply see out message here. Why? Because the message already has some error information, so I don't need to write anything. I just, whatever I get as an argument, it is an error message, I just display it to the user. Okay, and then in the default catch block, okay, I can write some unknown error. Okay, so now let's try to run this program. In case there is no error, it will compile. So yes, you see, A was 10, B was 2. So we are dividing 10 by 2. So answer is 5. Okay, so it means try block is executed completely because there was no error. Since there was no error, none of the catch blocks is executed. The first catch block is not executed, the second is not executed, and then whatever is after the catch block is executed. So you see on the screen, answer of division is 5 and program continues. Okay, now let's make denominator equal to 0. Now we are trying to divide by 0. So when b is 0, b is copied in this y, denominator is 0, so it will throw a string, it will throw a message, right? So now this program should not give me an answer of division, rather it should give me an error message, that division by 0 error. Now you see, when b was 0, we say division by 0. Okay, this is the message we displayed, we throw. When we throw, it comes into this variable message, and in the cache block we write cout message. So you see this error message on the screen, division by 0. Okay, so now you see, we can you can make any error message, division by 0 error, denominator cannot be 0. Okay, means you can make any error message. So now the advantage is that if there are many functions which are throwing errors, every function will have a customized error message. Okay, so you don't need to worry, you can simply throw the error message and you can display. So the advantage is that this is one function. If there are two functions, three functions, you can have a customized error message in each of the function, and the same catch block would simply display that message to the user, right? So this was another example in which, rather than throwing the exception within the try block, what we have done, we have made a function, that function is throwing exception, and we are calling that function from within the try block, right? So now from this example, if there are any comments, we can discuss those. Thank you. Okay, now we'll be further extending our discussion, that you see, what we are throwing so far, either it is an integer or a float or a message, right? So we'll be further extending this idea, and we say, since we are doing object-oriented programming, so we say, okay, why not make a class to handle the exception? Okay, so you see, we'll make a class, but that class will not be doing anything. The job of that class would be to deal with the exception, right? For example, if you are making a program for student, faculty, university, things like that, so you'll have separate classes in which your business logic will reside. Student, faculty, you calculate GPA, you calculate salaries and so on, right? But you will have a separate class, and the job of that class will be only to handle the exception. Okay, so let's keep the same example and let's introduce a class in that, and that class will be responsible for you can say handling the exception. Okay, so let me make a class. Okay, and the name of this class would be something like whatever you want to name that error, right? For example, we call it divide by zero error, right? This is our class and this is a name of error we have thought of, right? You can think of any name. You can call it division by zero exception, you can call it um, divide exception, divide error, anything, right? So this is a class we are making, and the job of this class would be to store data that is related to the error, right? Nothing else. This class is not doing any functionality. This is just you can say designed so that it can store data related to an error. Okay, so normally in this class you will not have many data members, right? You will have one or two data members depending upon what you want to do. So what we do is we say, okay, we take a data member which is like string and which is error message. Okay, because it makes sense that since we are making this class to store data, so the data member is a string which is actually the error message that we want to show to the user. Okay, and in the functions, again, you don't need any functionality in this class, so you can simply make a constructor and a get method and that's it, nothing else, right? Because nothing else is required in this class. We just want this class to store our error messages and then display error messages to the user. Okay, so now what I will do, I will simply make a constructor in this class and I will also make just one get method and that's it. Okay, so let me make a constructor first, divide by zero error, which accepts an string s, and I write here error message is s. Okay, this we have already been doing, just simply the name of the class is slightly unique, otherwise you have already been doing it many times. And then I also get make a get function which is get error message, in which we simply write return error message. Okay, so that's it. Now you see this is the end of the class. So what do we have in class? A string which will store our error message, a constructor and a get function. That's it, nothing else. Okay, now within this divide function, what we do, whenever there is an error, instead of throwing an integer or a float or a character or a message directly, you will throw an object of the error class, right? In other words, why did we make this class? We made this class so that we can store error data in the class, and whenever there is an error, you will throw an object of this class, right? So instead of writing this message, what I will do here, I will create an object of the class and I will throw it. Okay, so see, I'm creating an object of this class, and in the constructor you can pass any error message. For example, I'm writing division by zero has occurred. Okay, now you see this syntax can be slightly new for you, not new maybe. I'll just recall that what we are doing here. If you remember, when we are returning something from the function, okay, suppose you are returning a point from the function. So this is some function which is returning a point class, so point f. Okay, so one way is that you write point p and you call the constructor and you write return p. Okay, this is one way of doing it. It means there are two statements. First you create an object and then return it. But another way of writing exactly the same thing is that maybe I can write here. I write point f, and within one statement you can write return. You create an object, you just write point 2 3. Okay, so both of these are exactly the same thing. First, in the first one, you first create an object p and then you return p. Okay, here what we do, we combine both of these statements in a single statement. We write return 0.23. It means we are creating an object but there is no variable name, there is no p. Okay, so both of these are exactly the same thing. So in the throw we are doing the same thing, right? For example, if you want to throw a point, so what you can do, you can first write point p 3, and then you can write throw p. That is good, that is fine. But the same thing can also be written as, you can simply write throw point 3, and both of these are actually same. We are just you can say this is a shortcut expression. We are just saving one statement and we are doing it in a single statement. Okay, so now let's come back here. So here we are doing the same thing. We are creating an object of this class, we are calling its constructor, and we are throwing it. Okay, so now what you are throwing, you are throwing an object of this class. So whatever you throw, you catch the same thing. So it means now I have to change this catch block. Okay, and I will also need to change this. So now when I am throwing an object of this class, the same I'm catching here, divide by 0 error, and let's call the object E. Okay, now you see this object is what you are throwing from here. Now this object has all the information of this error. Why? Because when you created this object, what did you pass in constructor? This message. And where did this message go? It goes to S, and from S now it is stored in this variable error message. So whenever you want to print the error message, all you need to do is you can write C out E dot get error message. Now it will, the output would be more or less exactly the same what you were getting previously, but now our program is much more elegant. Now you see what is happening. We are throwing an object of this class, and when we create an object, we store the error message in this class. So this string error message is storing your error message. Okay, now the advantage is that if you are throwing error from different functions, you can have different error message. You don't need to worry here what you need to print. You simply write c dot get error message, and then you will see the error message on the screen. Okay, so let's see what it gives us as an output. Okay, now you see it is giving us division by 0 has occurred. When you call e dot get error message, you get this error message. And what did you set in this error message? This string. If you want to change this error message, you can simply throw an object by changing this text, and then the same will be printed here, right? So let me show you this example because it's not very straightforward. So let's discuss it from here. Yeah, this is the same example. Okay, so you see what we do. We 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 have a class divide by 0 error, right? Previously I was storing string. In the example that I made here, I am storing the integer, which is the denominator, which is the error data, right? So this is the constructor, this is the get method. So as I told you, in the class that you are making to handle error, you don't need any functionality, you just need some data, a constructor and get method, that's it, right? Other than that, there will be nothing in the class. So now this was the function which was performing division. If the denominator is 0, you write throw divide by 0 exception. And in this example I am passing it b, right? That instead of storing the error message, you can also store the invalid value, because b was the invalid value, so we are storing here. And then you can call this function from within the try block, right? So we have x, y, and z. We call this function. If there is an exception, we have this catch block. Now you see what is the argument of this catch block. The argument of this catch block is an object of this class, because whatever you throw, you see here we are throwing an object of this class, so we are catching it. Whatever you throw, you have to catch exactly the same thing, right? And now we'll do one more example related to this. Okay, and then maybe we can have a discussion session, so that things are clear. Okay, so maybe it's better if I write the program rather than on the board, because then maybe it would be easier for you to follow stepwise. Okay, so let me just get rid of this, and let me make a slightly different program. Okay, so now what we do is, now we make you see we have made a class for exception, but our whole of the program is still in the main. Okay, but since we are studying object oriented programming, so we'll have classes, and the exception will be thrown by the functions of that class. Okay, so this is what we want to do. So now what we'll do, suppose we want to deal with rectangle, so we'll have a class rectangle, and a rectangle has maybe length and width. For some time, let's forget about any error. Let's say this was our program, we have a rectangle class, we want to compute area of a rectangle, right? So we say, okay, in public we make a constructor rectangle teacher, length is 1, your width is 1, right? Or maybe I call it say 10 and 2 5, and we say length gets the value of L and width gets the value W. And then we can also make a function int get area, and within this function we can write return length into width. Okay, so now this is a rectangle class. Okay, we are computing area of the rectangle. You can compute many other things like parameter or anything. Okay, you can have a display function. Let me just make one more function, void display. Okay, and you write c out length is this. Okay, and width is okay. So you see we have a rectangle class. Length and width are two data members. You have a constructor in the class, you have a function which calculates the area of the class, and you have a function which is displaying the length and width of the class. Okay, now suppose some function in this class can generate an error. Okay, for example, what could be an error? We say length cannot be less than width. So if some user is creating an object in the main, like say rectangle R, he says length is 2 and width is 10. So this is actually, you see, not correct, because length must be greater than width. So if he wants to create an object, he should write 10 2. Okay, this is our definition of error. You can have any other definition of error depending upon the scenario. Okay, so we say that length should always be greater than width, which makes sense, right? In a rectangle, length is always greater than width. Now if this situation arises, we'll throw an exception, we'll throw an error. Now the difference is that, you see, this is the class which is the requirement of your program. Someone has asked you, your client has asked you that they need a class in which they can create rectangles, they can create compute area parameter, and so on, right? Now in order to handle the exception, you will make a separate class, okay, which will be different from it, and you will give it a name. For example, we call it error class. Okay, so this class error is different from the program requirements. Program requirements were rectangle. You have done that, it is complete. Now in order to improve your program, you are making a separate class which is called error, and this is only to deal with the errors which might occur when the program is executing. Okay, so now just like previously, what do we put in class? We simply put an error message. Okay, and we just make a constructor in this class. So this is the constructor, so we say string s, and error message gets the value s, and we can make a get function, string get error message, and here you will have return error message. Okay, so now this is your error class, and this is your actual class which was required. Okay, now what we do now, you see, constructor is where we are setting values. Okay, so constructor is the place where error can occur. So what you will do, that you will put an if condition in the constructor. You will check whether you have legal values or not. Okay, so within the constructor, before assigning values, we check if length is less than or equal to width. Now you see, it means there is an error. Length cannot be less than width. If your length is less than width or equal to width, then there is an error. So now what you will do, if there is an error, you will throw an object of the error class, and what you pass, as an argument to the constructor any error message. We say error message is length cannot be less than width. So this is our error message that we are passing. Okay, so if you are making an object of a class and a user is providing values where length is less than width, the error will occur. If this is not the case, then this statement will not execute, and whatever values user has passed, they will be copied in the variable length and width. Now let's quickly write the main. Okay, and let's see how things will work. Okay, so this is the try block, this is the catch block. I'll complete it later. So in try, what you do, you simply write rectangle r2 comma 10. Rather, first let me make a correct one, and then you can call r dot display or r dot area, whatever you like. Okay, and if an error has occurred, then in the catch block, what you expect as an argument, an object of the error class. Okay, because what you are throwing here, an object of the error class. So the catch block will have an object of the error class, and here you can simply write cout e dot get error message and line. Now what will happen if there is no error? Okay, I am providing length which is greater than width. The constructor is called. We come to the constructor. Length is less than width. This condition is false. So the throw statement will not be executed. Whatever you passed, the first argument goes to variable length. The second argument goes to variable width. It means there is no error. The constructor is executed successfully. It will display the length and width, and your program will terminate. Catch block will not be executed because there is no error. Now, if we change the position of 5 and 10, now length is less than width. Now what will happen? This if condition is true. When the if condition is true, what will happen? You will directly jump to the catch block and you will display an error message to the user. So in that case, since this constructor had an error, so the rest of the try block is skipped. It means r.display is never executed. Why never executed? Because when you were executing the constructor, there was an error, and as soon as the program arrives at the throw statement, from throw it will directly go to the catch block. It will skip these two statements, and it will also skip rest of the try block. It will directly go to the catch block where you can display an error message to the user, right? So the idea is, what is important is that um, whatever program you are making, since we are into object oriented programming, will have classes. Class has data and functions. So there are functions in the class which can cause an exception, right? So for example, in this case, I have shown you rectangle class. It can be something else. For example, if it's a time class, so you see minutes cannot be greater than 60, cannot be negative, r cannot be greater than 23, less than 0, right? So similarly, you can throw exception from the set functions, right? Because this is a constructor, but a set function can also assign illegal values. So functions in the class will throw an error, and that error will be caught in a catch block. But the important thing is that you have one class which is the requirement of your program. You need student class, you need rectangle class or a circle class, right? That is separate. Other than that, you will have a separate class for error, which will be responsible for storing the data related to that error, and it is the object of this class that you will throw. And it is very much possible that in the same program you can have multiple types of error, right? For example, this is error which is dealing with length and width. You can also have an error which is dealing with something else. So within the same program, you can have multiple error classes, and depending upon what type of error it is, you will throw an object of that class. Okay, but that is something advanced. So even if for the time being you can stick to one error class, that is perfectly fine, right? So this was one complete example of exception handling. It is also in your lecture slides along with some other examples, right? So now we have some few minutes left. So if you have any comments or you want to discuss something, we can do that.